Okay, so we've been talking about arcs and central angles and how they're related. And so a central angle and an arc, one of the ways that they're related is that if you take the angle measure of the central angle, so in this case that's 45 degrees, then the arc right here that's associated with would be 45 degrees. Now, this is called, maybe a little more precisely, called the intercepted arc. So if you take the central angle and the arc measure that's in between the two endpoints of these radii, so E and F, let's say, here we have arc FE. So the measure of arc FE would be 45 degrees, whereas the central angle, the measure is 45 degrees as well. So it's similar. So initially we talked about how the measure began. We had the Earth traveling in an orbit around the sun, and so let's say 45 days, it goes 45 degrees. That's according to the Egyptians. Okay, so if we just stop from here to here, that's 45 degrees. Now if we stop and then we continue traveling along, so from here to here, the central angle right here would be 39 degrees. So that's 39 degrees. That's 45 degrees. So this arc, GF, is going to be the same as that, which is 39 degrees. If instead of stopping, we travel here, this would be the same. The rotation would be exactly the same. So what we're going to be able to do is we're going to be able to say two arcs that are adjacent. Okay? That means they share a common endpoint. They're adjacent. You can add those together to get the total arc measure. That the arc measure postulate. So measure of arc GF, that doesn't look like a very good F, plus the measure of arc FE is going to be equal to the measure of arc GFE. Now this particular arc, because it's a minor arc, we don't need to use three letters. It would be, you can also write it like this, but either one would work. That's the arc measure postulate.